Hello guys, this is Dr. Possibility from Excel Academy. In today's class, I'm just simply going to explain to you on how you can state whether a given function is a one-to-one function or not a one-to-one function. So let's quickly get started. So one thing you need to know is that you need to be able to identify a given function if it's a one-to-one function or not. So for a function to be a one-to-one function, for a function to be a one-to-one function, the following should be obeyed. 1, f of x1 should be equal to f of x2, or in simple terms we can say x1 should be equal to x2. So this is what I'm using, but in some books you find that they don't use x1 or x2. Instead, in some books, for some books they'll say f of a should be equal to f of b, of which you can say or a should be equal to what b. So for some books they use that, for some books they'll use what I have used. Okay, so let's quickly look at some few examples. Please make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. So my example is determine whether the following is a one-to-one function or not. So we need to state whether the following functions are one-to-one functions or not one-to-one functions. So let's quickly look at some few examples without wasting time. So the first example I'm going to give is this one. Let's say I have f of x is equal to 3x minus 4. So I'll write my solution like that. So for a function to be one-to-one function, f of x1 should be equal to f of x2. For a function to be a one-to-one function. So in this case, this is what we are going to say. We are going to say taking f of x1. So you can say taking f of what? x1. So in this case, you are going to say such that f of x1 is simply equal to 3x1 minus what? 4. So you write that. And then you say taking f of x2 such that f of x2 should be equal to 3x2 minus what? 4. So where are these x1, x2 coming from? So this x1 and x2 are coming from the fact that where we have in this expression f of x is equal to 3x minus 4, where there is x we are putting what? x1 when we take f of x1. Then where there is x we put x2, where when we take what? f of x2. Now because we are saying f of x1 should be equal to f of what? x2, therefore we can simply say 3x1 minus 4 should be equal to 3x2 minus what? 4. in this case, we are going to do what? We are going to take this 4 to the other side. So let's quickly take this 4 to the other side. We are going to have what? We are going to have something like 3x1 is equal to 3x2 minus 4 plus what? 4. Since this negative 4 minus 4 is simply equal to 0. So our next part is going to have 3x1 is equal to 3x2. Since we have that, what we are going to do next is we are going to divide throughout by what? By 3. So we are going to say over 3, again there over 3. When we do that, you're going to observe that this 3 and that 3 will go, this 3 and that 3 will go. So our answer is x1 is equal to what? X2. So according to our definition, for a function to be a one-to-one function, x1 should be equal to what? X2. So we are going to say, since x1 is equal to x2, the function f of x is a what? A one-to-one function. So this is how easily you can find this. Very simple and very easy. Please make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. Remember, during physical classes, we are going to give more examples and we are going to explain more using exam questions, because our goal is to make sure that you students understand all our concepts. Let's look at our next example. So our next example, let's say you have x squared, okay, x squared plus 5 is simply equal to f of x, okay, or we can say f of x is equal to x squared plus what? 5. Then what we are going to do is, for a function, we're going to say solution. For a function to be a one-to-one function, f of x1 should be equal to what? F of x2. Okay, so in this case, what we are going to say is, where there is x, we are going to put what we are going to say. So let's say taking f of x1 such that we are going to say f of x1 is simply equal to what? Is simply equal to what we are going to give as x1 squared plus what? 5. Then we can say taking, okay, we can say taking f of x2 such that, okay, f of x2 is simply equal to x2 squared plus what? 5. Now, since we have said that for a function to be a one-to-one function, f of x1 should be equal to f of what? x2. So in this case, what we are going to do is we are going to get x1 squared plus 5, and we equate it to what? We equate it to x2 squared plus what? Plus 5. So like in the previous example, when you take this 5 to this side, it's going to be what? Negative 5, isn't it? So it's going to be 0. So since we have such a situation, this means that x squared 1 is going to be x squared what? 2. Now, in this case, you need to choose which side do you want to get rid of a squared. So in this case, I'm going to get my left hand side. So I'm going to say x squared 1 is equal to what? X squared 2. Then what I'm going to do is I'm going to introduce a square root on this side, and then I'll also introduce a squared on this side. So here, because I've introduced a squared, this will be positive or negative. Then that means that this guy and that guy can go. Remember, I've used this part to get rid of what? To get rid of a square root. So after doing that, I'm surely going to have something like this. I'm going to have x1 is equal to what? Positive or negative x2. Okay, this means that x1, this means that x1 is equal to positive x2, or x1 is simply equal to negative what? X2. Now, because this guy is producing two results, which is this result and that result, this means that this function is not a one-to-one function. So we're going to say since x1 or f of x1 has two products, okay, two products of f of x2, the function, okay, the function f of x is not a 1-to-1 function, is not a 1-to-1 what? Function. So this is how easily this function can be. So summary, if I was to make a summary of what I've just explained, so let's look at the 1-to-1. Let's look at the 1-to-1 and the not 1-to-1, not 1-to-1. So when you talk of a 1-to-1, let's say you have, this is your x. So this x, it is the domain, and the domain is having the product, like let's say A, B, C. Okay, these are the members of set A. And then you have set Y, which is your range. So this range is also having the product, let's say X, Y, Z. So for a function to be a 1-to-1 function, each domain should have only one range. Okay, so in this case, A is only having Z, and B is only having X, and C is only having what? Y. Then when you talk of a not 1-to-1 function, let's say you have this as your X, and this X is your domain, which is having the following members, let's say A, B, C. And then the other one, let's say you have your Y there, and this Y is having W, let's say W, X, Y. And then when you work out this, you discover that maybe one of these is having two products or two ranges. Then this guy is not a 1-to-1 function, is not a 1-to-1 function. So that's how easily you can identify a 1-to-1 function. For example, in our example, if you observe, the first example is stated to be a 1-to-1 function, the domain at x1, okay, and it gave out what? X2 only. Okay, this is what the relationship B had to show. But for that one, which was not a 1-to-1 function, let's say we had x, y. So for that one, we had a domain which we used as x1, and we also had the range. Now the range has two products. It has x2 and the negative x2. So this was giving us something like that one there, and also that one there. So this one is 1 to 1, this one is 1 to 1, and this one is not 1 to 1. Okay, so this is the basic concepts that each one of us is supposed to know before our final exam. So please subscribe to our YouTube channel and make sure that you get in touch with me on positive 26 09748406616. Thank you very much. This was Dr. Possibility from Excel Academy. Have a blessed evening and day.